Hello. Um, Hi. Hello, folks. I hope I'm audible. Good evening. Hello, hello everyone. We'll start in a minute. Let everyone join. Um, Good evening, fellows. I hope you were. I hope you are having a good day, and also you got time to attempt the assignment which was given yesterday. I'll quickly give you the solution of the assignment. Right. So the question was to calculate NCR. Okay. So the question was to calculate NCR, and it was supposed to be done using recursions. Right. Now, of course, the one of the methods which you can think of is to write the factorial function. Right. We saw how we can write a factorial, how we can write the code to calculate factorial using recursion. Now, that was one of the options. I hope you also know how, I mean, what is the formula? Okay, it is very simple mathematics only. It is n factorial divided by n minus r factorial um, multiplied by r factorial. Right. So yeah. This is the formula for NCR. Right. I hope you remember this. Now this was what is supposed to be calculated. Okay. The input would be n and r, okay, and the output should be the NCR, okay. Now factorial, of course, as I had said before, you could have done attempted this by making a function for calculating factorial, and then simply just computed this yeah this expression, right? How would you do that? You would do that. Let's just take our factorial function. Um, yeah. So let's just take the factorial function. Yeah. So in the factorial function, like I can I'll show how it runs first. So if I call the function like this, Okay, it's starting to connect. Okay. Yeah. So if I call the function, it returns me the value, right? 5 factorial is 120. Now, what you can also do is you can do something like 10, a factorial of 10 divided by factorial of 10 minus, let us say, 3 times factorial of 3, right? So this is for 10C3. Now, of course, this is one of the methods. Okay. This is one of the methods. I hope it's calculated correctly. Yeah, 10 times 9 times 8 divided by 6. Yeah. So this is one of the method, but then this is not the most elegant solution, right? As engineers, as computer science engineers or any engineer, your primary focus should be to come up with some elegant solution which like does not, elegant solution is which is crystal concise. So the elegant solution would be something doing it. I mean, writing a single function for doing the computation. So what we do here is we use the Pascal's triangle property. Okay. Many of you also figured it out. As I was looking through the solutions, many of you figured it out. The Pascal's triangle property and this thing, right? So please note, if you remember, I had said in the previous session that we can pass multiple arguments inside a function. Okay. So if your code block requires multiple inputs, you can pass multiple arguments in it. So just so we are passing multiple arguments here. Now, what is the Pascal's triangle property? N minus one C R minus one plus N minus one C R gives N C R. Right. Sorry for the noise. Yeah. So N minus one C R minus one plus N minus one C R gives N C R. Right. So this is the Pascal's triangle property. Now, how exactly we write this code is, okay, how exactly do we write this code? So we define something called base cases. Okay, we define something called base cases, and we actually how we wrote the factorial code. We call factorial 10. So what this does is this starts with 10 times. If you mark over here, this starts from 10 times factorial 9, right? And then this factorial 9 is later converted into 10 times, so this factorial 9 is later converted to 9 times factorial 8, right? So this 10 times factorial 9 basically becomes 10 times 9 times factorial 8. And similarly, this loops, this is not exactly a loop, this is a recursion. This similarly, the recursion continues, right? It keeps continuing until it hits the base case. And what is the base case? The base case is this. So if the argument becomes 0 or 1 because of some reason, now it won't become 0. So you can actually, neglect this. Or it may. Wait, it might as well be, it might become 0 if we call like factorial 1. No, it won't. So it won't be 0. So you can actually neglect this n equal to 0 condition, right? So you can neglect this n equals to 0 condition and still the code would run. So let's just see whether it runs or not. It does run. Okay. So so this is the recursion I told you about, right? So this recursion continues until it hits this base case. This base case is n equals to 1. So when n equals to 1, we see a return of 1. Okay. So this will continue um, until finally it reaches 10 times 9 times 8 times 7 times 6 times 5 times dot 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 2 times this factorial 1. So factorial 1, when we call factorial 1, this first if condition holds true. So this first if condition holds true, we see a return of 1. So this factorial 1 becomes 1. So what we get in return is this thing, okay, which is nothing but the factorial of 10, right? Now, one more thing I have to say that you don't really need to write this else. Now, how the flow actually occurs is it Python first executes the first line, which is a comment, so it ignores. Then it executes the second line. Then it executes. So the second line is nothing but a if condition, right? So if the if is true, either if the condition inside if is true, then it executes this line, or else it just moves to this line, or else okay, it's not going. So, or else it moves to the else line, okay, and in else it runs the else code block, right? So, but okay, but if the this condition, if the if condition holds true, then it will run this return thing. Now in Python, if inside a function we like this return keyword gets executed, the code does not move any forward. Okay, the code won't move any forward. So if this returns, if this programming instruction gets executed, these would be conveniently ignored. Even anything we write here, now there is a else, right? Now there is a else, so it is anyways getting ignored. But let us say we had something like print one. Okay, so this entire portion would be ignored by it. So you actually don't need this else, right? If you think of it a little, you actually don't need the else. You can conveniently write this return n times n, and this should give you the same return. This should give you the same value as return, right? So the flow is like halted at the return statement. The flow inside a function code block is halted at the return statement. So the flow is halted at the return statement. Where right now, moving on to our next code, right? So here the base cases. So base cases are what, like so recursion moves from like top to down. This recursion is kind of moving from top to down. So it moves from n comma r and it goes till okay, yeah. So it starts from n comma r and it goes till the point, since at each step, okay, at each step it is subtracting something out of n and r. So it will go till the point where either r equals to 0 or r equals to n, or r becomes greater than n, or r becomes less than 0. So these are the base cases, right? So what basically this does is, I'll delete this or just put it inside quotes. So this is a comment. So what this basically does is, let us say I wrote NCR basic and I wrote it like 10 comma 3. Fine. So it will first run this code block. This if condition holds incorrect. This another if condition also holds incorrect. Ideally, you might have thought this should have been elif or something like that. But then since this return gets terminates the flow, we can like simplify this. So first we call, let's say, NCR basic 10 comma 3. What happens next is let's just first run it. Oh, we have to first run this code and then we run it. Yeah, this gives the right answer. So what happens is when you call NCR basic, these two base cases are like don't hold correct, right? So it will move to the final thing. This will move to the final thing. And here what it does is when I call NCR basic, it basically returns me 9 comma 2, and this is again 9 comma 3. So this NCR basic 10 comma 3 now becomes NCR basic 9 comma 2 and NCR basic 9 comma 3, right? This 9 comma 2 further becomes what? This 9 comma 2 further becomes 8 comma 1 plus 8 comma 2, right? And this NCR basic 9 comma 3, this becomes 8 comma 2 and 8 comma 3, right? So at each step, it keeps expanding this expression, right? So at each step, it keeps expanding. Now here, mark here that we have reached 8 comma 1 here, right? Still the base cases aren't correct. When the base cases would be correct at the next step, you'll see when we reach somewhere like 8 comma 0, you'll see the one of the base cases will hold true. So at that point, this code block would halt at return equals to 1. So when I reach to sorry, not 8 comma 0, 1, 7 comma 0, we in the next step we'll reach to 7 comma 0. So at 7 comma 0, you'll see that this base case actually holds true, and 7 comma 0 is replaced by 1, right? Similarly, for when this base case somehow holds correct, again, the it gets return it converted to 0. So similarly, this triangle keeps executing. So you see, this is a triangle, right? This sort of looks like a triangle. It keeps continuing until um, somewhere at the bottom, okay, it hits the base cases. Okay. At at the bottom line, there are only base cases. So this basically concludes yesterday's assignment. Right. I hope you had fun solving it. And yeah. Now coming to today's session. Right. Before we start with today's session, please remember to mark your attendance. I think the attendance form has been circulated as well. Please mark your attendance. Do remember that yeah, there is this free internship as campus ambassador with Corso. If you like want to be a part, please do apply for it. Okay, just press the yes. Uh, Remaining thing I think are self-explanatory. To please do fill the form, attendance form. You need to fill it for all 5 days to be able to be eligible for the certificate. Right. Now moving on to day 3. Right. Day 3. So yeah, we yesterday we left at some numpy functions, right? So we'll quickly recap through that, and we'll proceed with today's contents, right? So yeah, so we saw what was ND array, right? We saw what was ND array, homogeneous n-dimensional array, fixed size, contiguous memory, vectorized operation, foundation for advanced libraries. We also saw the methods in which we can create a numpy array, right? Or we can create an ND array. These are all the methods. The slides were circulated yesterday. I hope you got time to look through it. Um, we can also create you know, two-dimensional lists. We also saw how we can create two-dimensional lists and how it can be extended to create two-dimensional NumPy arrays, ND arrays, and subsequently an extension to it called the NumPy matrix. So these are the two crucial data types we went through yesterday, and we saw the different you know we saw something called the shape. Okay? We saw something called the shape of a ND array. Okay? The outermost value is basically the number of elements present in the outermost whatever vector. The innermost value is the number of elements present in the innermost vector. Now, all vectors have to be of the same size since it needs to be homogeneous, right? So this variable size is not really a problem. We saw how we can access the different attributes associated with a NumPy array or ND array, right? These attributes are pretty self-explanatory. Just put them in print. You'll see the different attributes associated with a NumPy array. We did make a NumPy array yesterday in Colab. Okay, I hope you are able to like access the Colab notebook which are circulated, right? And please This is a pretty you know user the user interface is pretty good. Okay, with Collab, this is really good user interface. It offers like these boxes where you can put or I mean put all your code and execute them, and it also stores the variables, right? Any function, any variable you make, it is also accessible in the further codes, in the further boxes, right? So it's a very user good tool, right, for learning. If you want to make like new boxes, just go here, somewhere here, and you'll see a plus code sign. This will make a new box for you to code. If you like want to do it another way, just press escape 2 times and press B. It should be able to make a new box. If you're making it below the current box, if you're trying to make it above it, just press escape once or twice until this flickering goes and press A. So escape plus A, escape plus B, these are the two methods of making new code boxes. But then nevertheless, you can just try this, right? You can just try this. This way you can make new code boxes, write your code, and execute them, right? Very simple, good user interface. Um, and apart from this, yeah, so these are all the attributes associated with an NumPy array. I would reiterate the fact that NumPy arrays are nothing but objects and part of the object-oriented programming of Python. Okay, this is a little beyond the scope of this session, and I mean in this entire boot camp. If you are like interested, I would encourage you to try to learn about it. This is not a very difficult concept, but takes a little time to understand. We'll go move. Yeah, this is where we stop. Okay, indexing and slicing. Um, so we saw one-dimensional slicing, which is basically borrowed from lists, right? Now this is okay. Now this is something I think which we did not cover in the list. Like we can slice in different manners. So we'll quickly do that now, right? We'll quickly do that. So I'll first make a list, right? If I do 0 to 2, this gives me the numbers at places 0 and 1, right? This 2 is ignored. If I do, if I just ignore this 0, still if I ignore this 0, it will start from the beginning and it will go just before the index 2, right? So at 2 we have 3, so it will go till 1, 2, right? It will go only till here. I hope you are able to see this. So it will go only till here, it would not go till here. If I do 2 to end, right, I'll print all of them. So if I do 2 till end, now this 2 is, it starts from 2, it goes till end, right? Starts from 2, it goes till end. And if I do something like this starts from beginning, goes till end, right? And you also have the feature of like selecting the step, right? So if I just do like this, the default step is 1. 1 means every index, like the in some the indexes are progress by a step 1. So 0 plus 0 plus 1 1, 1 plus 1 2, and then that's how it progresses. If I can change this step, right? So I can change this step. For that I just have to like put one more colon and write something there. So I'll change this step. So what this code will do is, let me run it. This code prints only 1 and 3. So what this code does is, this starts from the beginning, goes till the end, but at a step 2. So starting is index 0, then it goes 0 plus 2. It goes to index 2, and then it goes. Then beyond this, it cannot like jump by a step of 2. So it stops there. So it predicts one. It not predicts. It returns 1 and it returns 3, right? So that's how it does. So again, I would encourage you to play around a bit about, over this slicing and see how it, you know, oops, see how it operates. And yeah, with that, we'll move to the NumPy slicing. So we saw the multidimensional slices, right? How we can do multidimensional slicing. Now, with list, we saw how we can do multidimensional um, slicing. With list, we can do with list as well. We can do, multidimensional slice indexing and slicing. We saw how we can do indexing, multidimensional indexing. In the similar manner, we can do slicing as well. But in NumPy is a little special. Okay. So this was our array. I added one more, you know, element to this so that it's easier for us to see. Um, so we saw we can access like we can have this advanced indexing. So I'll just do this. So it first prints the array. It next prints. So outer index 1. So outer index means this list, and inner index is 2. So this vector ka this number. So this prints 6. Right. Similarly, you can like print around a bit more, like 0, comma 1. This prints 2. So outer index 0 and inner index 1. Right. I hope you are able to follow. So this prints 2. You can also do like multi-dimensional slicing as well. Outer index, I want all of them, and inner index, I only want one. So outer index, I want all of them. So all these lists would be like taken, but inner index, I only want one. So only these would be printed, right? If I print this, this gives me 2537. So 2, 5, 3, and 7. Right. This is how you can like do this advanced here. So if you like think of it a little bit, this is like a table, right? So the outer indices are basically row indices, and the inner indices, right? The inner indices are basically column indices. So when I write something like this, I want all rows should be there, but column should be like zero, first index column, or which is the second column, right? I can also print multiple columns, add I want all rows, and I want all the columns from one. So if I do this, so it printed that as well, right? So all rows, right? All rows, but I want columns from starting from one, right? So I get this column, right? I get this column, and I get this column as well, right? So I get this column as well. So this is how multidimensional, slicing works. I can also do something even more than this. Like, I can like selectively, select selectively pick elements, right? So in this way, what I do is I enter two tuples. And this also, let me have a tuple only here. I can enter tuple. I can even enter a list. Okay. So what this does is outer index I want 0, 2, and 3, and inner index I want like so inner index I want 0, 1, and 2, right? So how it will work then is it will select the outer index 0, 2, 3, and the inner index would be yeah, so it will select the outer index 0, 2, 3, sorry, 0, 2, and 3, and the inner index would be 0, 1, and 2. So in the first index, the zero in the zeroth index, it selects 0. In the second index, right? In the second index, it selects 1, so it selects 3. In the third index, right? In the third index, it selects 2. So which is the second index, which is the 1. So it will return this, this, and this, right? So this is which is basically 1, 3, and 1, right? So this is what it returns. Sort of, I mean, might appear a little overwhelming, but then you see what, I mean, how much power you get, right? You can like selectively pick numbers out of an array, right? You can play. I would definitely encourage you to play around more with this, right? This would be really helpful for you when you're making, especially when you're trying going for game development. Right? This would be really helpful when you go for game development because game development is all about matrices, right? It's all about matrices, vectors. So it will be completely based on NumPy arrays. Okay. So yeah, I hope you guys are able to follow this. Right. The next is yeah, advanced assignments. So as I had said, you can not only slice and pick up sub arrays, you can also assign numbers on those positions. Like here, right? What I'll try to do is I'll do some assignments. I'll assign this. You can enter a NumPy array. You can also enter a list as well. 99, 99, 99, and then now I'll print the array. Okay, maybe I'll enter something better. 10, no, 98, 99, 100. Now I'll after this assignment, let me print this array. So you see what positions were being picked, right? You will see what positions were being picked, and those positions are now edited, right? Those positions are now edited. So it was 023, 012. Okay, I'll clear this garbage for the time being, and so that it does not like appear in the display. So the previous array was 1, 2, 3, 4, 5, 6, 2, 3, 4, and 4, 7, 1. What I selected was 0, 2, 3. So 0, 2, 3, and inner indices were 0, 1, 2. So 0 for 0 I select 0, for 2 I select 1, and for 3 I select 2. So those numbers are edited now. Right. So this is how you can manipulate a NumPy array. You can change it. You can selectively pick values, selectively assign values as well. Right. So this is fancy indexing. We also saw how we can do Boolean indexing. Right. So we'll just quickly recap it. Yep. So it just entered what all places. I mean, it just entered a sub array, consisting all the values which are greater than 4. Now this might not be very helpful. Like I can, okay, I did this slicing, but what I get out of it, I don't get anything. So for this, we have. Okay, let me just print this again. Right. So I just get a sub array which has like values greater than 4, but I don't really get anything out of it. If you think like, okay, I get a sub array, but then what use it is of to me, right? It's not no use. So for this, we use a very special function called np.where, and inside we just put this condition, right? So what this does is that this gives me all the indices, right? All the indices where this condition holds true. So at 0, 0, this holds true. Right? Okay. Okay. Then wait. Yeah. Print array. Sorry for the for the typo. Yeah. So at 0, 0, this holds true, right? So at 0, 0, this holds true. At 1, 1, this holds true, right? So 1, 1, this holds true. At 1, um, 2 as well, this holds true. So at 1 and 2, this holds true, right? So one index, and 1 for one index, 2. So at 1, 2, this holds true. Again, this holds true at 3. So 3, 3, 1. So it holds true for 3, 1. Right. I hope you guys are able to follow. So this is more important function, right? np.where, this is a more important function for us. Like this gives us the indices, so we can change those indices. You will see later in this session how this can be more helpful to you. Now we'll move into the next part, which is what operations we can do over there, right? So we'll start with the aggregate operations, the common operations. Like if you want to find the sum of the array, if you find the mean of the array, if you want to find the minimum value, the maximum value, or the standard deviation. I hope you remember the formula for standard deviation, right? So let me just you know yeah. So this is a part of day 3. So I'll do this in day 3. Right. So array, we access it. So array dot sum. This gives the sum of it. Now, if I like want the sum of only the rows, right? The sum of all individual rows. Yeah. If I want the sum of all individual rows, I enter a keyword. Okay, a keyword argument. So this is called a keyword argument. Um, this gives me the sum of individual rows and right. And if I do, if I put the value of x as 0, this gives me the sum of individual columns, right? So in the similar way, you can do for mean as well. Like I'll replace this with mean, and this gives me the mean of all individual rows. If I don't put this axis, it by default assumes that it has to find the mean of the entire stuff, right? So similarly, you can just play around with these functions. Yeah, the access parameters which I just showed, and just keep them true. We put to preserve dimensions. So let's just try it. Right, array dot sum keep. Right, so it just preserves the dimension. So if it was like a two-dimensional array, it will return a two-dimensional array. Right, we'll just print it. If you can see, we are not really required to print it. It still shows the but my recommendation would be to like still print it. Maybe you can just play around a bit and figure out okay, when it shows and it doesn't. Right. So it preserves the dimension. It returns a two-dimensional array. Um, we can also do the vectorized operations. Now this is where I would like you guys to focus. Right. So we can do we can like play around with this array just like we play around with a mathematical vector. Now vectors can be added, vectors can be subtracted, and this multiplication is a slightly different multiplication. This is not the generic vector multiplication, the dot or cross product. This is array level multiplication. So element wise it multiplies. So 1 into 4, this gives me 4. 2 into 5, this gives me 10. 3 into 6, this gives me 18, right? So this is an array level operation, element wise operation. And similarly, we have a division as well, right? We can divide. It is also a array level element wise division. We also have this power of exponential operation. This is also element wise. Let's just try one of them, like print np dot array 1 comma 2 comma 3 star star no yep star np dot array 2 comma 2 comma 3. Maybe I'll just do 3 comma 2 comma 2. Just yeah. Sorry for the bugs. So this gives me 189, right? So 1 to the power 3 1, 2 to the power 3 8, 3 to the power 2 9. Right? And then this is the one I was talking about. This is the matrix multiplication, right? So you can like so NumPy supports matrix multiplication between ND arrays as well. Of course, you have like the matrix data type as well, where you can do this without this at the rate operator. You can do it by simple star. So, okay. Um, yeah. So this is broadcasting addition of different shapes. So what I'm doing is I have a one-dimensional array and I add it with a two-dimensional array, right? So what this does is think of it like a matrix, right? So I had a row one, two, three, and I add that row one, two, three to first, by one, and then by so I have a row one, two, three. I first add it with one and create a first row. Then I add it with two, create the second row. Then I add it with three and create the third row. Right. So in that way, it does like so 1 plus 1, 2, 2 plus 1, 3, 3 plus 1. Yeah, it's kind of self-explanatory, pretty user friendly. You can try this at your level as well in the Collab notebook or whatever medium you're using. Right. Next is this is sort of important. This is called shape manipulations. Now, first is this np.arrange. What is np.arrange? Let me just show you the code. Print np.arrange. Um, did I write the wrong spelling? Yeah, I think I write no spelling. So it gives me a array starting from 0 to 5, sort of the range like thing, right? Sort of like the range only. So I do this np.arrange. I then do a reshape, right? And reshape inside reshape, I input my target shape. What is the target shape I want? So I want the outer list to contain two, the inner list to contain three. So outer list contains two, the inner list contains three. I could have also done this in a slightly different manner. Like if I just reshape it here itself, the target shape I enter 2 comma 3, and let's see what it enters. This enters what you expect, right? 0 1 2 3 4 5. 0 1 2 3 4 5. Even if I don't enter this 3, now, and by now you should have like gotten key. Okay, this 2 times 3 has to be 6, right? If this 2 times 3 doesn't pay 6, then you screwed up. Uh, Even if I don't enter this 3, NumPy knows it has to be 3, right? Or else 6 won't be there. So even if you don't enter this 3, or you like don't want to calculate, let us say you don't want to calculate, or you just don't know what this number would be. Like you get some sort of variable, like in the form of a column. I gave a column as an input to you, let us say. So you don't really know what is the size of that column, but you just want the okay. Um, I want two rows. Whatever be the size of that column, you just reshape it into two rows, and this you take care of yourself. So for this purpose, we have this minus one thing. Okay, this minus one. If you write minus one here, NumPy would automatically calculate what should be the number. So this is again a very powerful feature of NumPy, right? So do remember this. Always write this. I mean, when you are unsure of what would be what is the shape of your ND array gonna be, you can always take the help of this minus one and let NumPy figure it out itself. As the next step, we have this ravel, which basically flattens the view, right? So this is all this is also pretty self-explanatory as well. This is called transpose operation, right? If you remember in matrices, we had this transpose operation. If you look at it, this is sort of a, you know, a matrix with say two rows and three columns. It will transpose it into a matrix of three rows and two columns, right? So, I mean, it's pretty self-explanatory. This T is transpose. This transpose also does the same thing only, right? So earlier this was, a matrix with a single row and three columns. Now it became a matrix. I'm sorry, I'm using the word matrix and arrays interchangeably. This is to be technically correct, an array, ND array. But it is like representing a mathematical matrix. So this was a array of one row, three columns. It changed to one column, three rows. Expand dims is add a new singleton access to it, like position 0. So basically, this we started with a array containing one-dimensional array containing 0, 1, 2, 3, 4, 5, and then we just expanded it to contain a one more additional dimension. Now it is a two-dimensional array. Okay, but the shape doesn't change. I mean, the shape the inner shape does not change. We just added a list from outside, an array from outside. Next is we have this squeeze operation. The squeeze operation just so in the previous thing we saw how we can expand the dimension, and the squeeze operation we see how we can reduce the dimension. So the squeeze operation reduces dimensions which are not very required. Uh, yeah. So yeah, I hope you guys are able to follow. Okay. So these are all the methods in which you can like manipulate the shape of the numpy array. Right. We'll move forward into directly pandas. Now this is a very important topic. Right. This is a very important tool. This is basically a Python library, but it is incredibly used around the globe for handling data and analyzing. Right. How it basically does stuff. We'll see how it does the stuff. Before that, we'll see what exactly is it used for. Now, pandas is specifically used, to handle tables. Its primary purpose is to handle tables. Just the way if you have ever used Excel, right? This is Excel. Its purpose is to handle tables. Similarly, pandas' purpose is also to handle tables. Right. You import pandas by writing import pandas as PD. Right? I hope you remember what is this import keyword and what are these libraries. Right. These libraries are basically a set of predefined functions and objects kept in a kept in a piece of code so that you don't have to like rewrite all those definitions into your code. Instead, you just write a single line and all those definitions are just borrowed into your, or to be specific, imported into your code, right? So we see this pandas. Let's proceed with it. Pandas offers two key data types. One is the series data type, which is a one-dimensional. This is basically a one-dimensional NumPy array extended to have like non-integral indices. I mean indices beyond integers. So we saw that one-dimensional array can have only integral indices. What if we want like non-integral indices as well? Just the way list and dictionary, the same way array and series. So the series is an extension of the 1D array, but it is now labeled, right? So this is now labeled. This has the capacity to contain non-integral indices. But please remember the indices still have to be immutable, right? They cannot be mutable. So yeah, how you create it? Let's see how you create it. It's just like you know, we write this PD. This PD is import pandas as PD. PD.cds. We write. We enter a list just the way we entered a list in NumPy array while creating a NumPy array. and we specify its index as well. So here we are specifying a string index. We can also do it using a dictionary. Okay, the keys will be indices, the values will be data. This is very self-explanatory, so I'm going a little fast. I hope you guys are able to follow. Right. So next is indexing and alignment. Right. So for indexing, we have this lock. This lock is used for accessing indices which are specified. Right. So we specified those indices earlier. If we don't specify indices, the default indices are integral 0, 0, 1, 2 till the n minus 1. Right. So if we want to access it through the indices we specified, we use the lock. And if we want to specify it through the default index, we use ilock. So let's just see it in action. Right. Let's just see it in action. So first we import pandas as pd, then we specify series, right, pd.series. If I don't specify anything, if I don't specify any index, it just becomes a numpy array only. You'll see. And if I specify a index, this becomes what? Let's specify something one A, B, C. So we'll execute this, then we print A, and we see this, right? So this is the index. The first is the index, the next is the values. And if we print B, again, so you now see the index. So A, B, C are the indices, and 1, 2, 3 are the values, right? It also mentions the D type, right? So in both NumPy arrays as well as the pandas series, as well as pandas data frame as well. I mean the other other data types as well have this D type attribute, right? So this D type is basically what is the type of data which is consisted inside it. So just like NumPy arrays, these are also homogeneous in nature and can have only single data type. Right. So this is how you can create a series. Right. The dictionary one is also there. I would leave that on to you to try. So let's see how we can like access an element through the index we created. So for that we use a. Okay, we'll use the variable b, and we'll access, but we don't access it like this. We access it like this. Lock. So b dot lock, and when we execute this, this gives me 1. So this is basically the value corresponding to a. We can still use ilock as well. Okay, ilock is the default index, right? So ilock gives this um, element at position 1, right? So this is how you can access elements, right, in the panda series. We can have this boolean and fancy indexing, right? We can have automatic alignment. So we have the automatic alignment in operations, right? From NP, just the way we operated over in NumPy arrays, in the similar way we can also operate over Panda series as well. This is basically an extension with custom indexing. That's it. Um, so these are all the operations which it supports, right? It's very similar to this to that NumPy array only. Just one difference, like Panda series also like supports, has a better support for missing values. In NumPy array also we can like still have missing values, but it is in a slightly different manner. Like here, let me just go to the here. At a particular position, let us say 1, I just remove it and put numpy np.nan, right? np.nan, and then we print it. When we print it, this shows a nan value. Nan means not available, value not available. We can still like index it, we can still access it, we can still change it or in whatever ways we want, we can still change it, right? So after doing this computation, let me just print. Right. So yeah, so when we did this operation, if you remember, we replaced these values. So this nan value also got replaced. Right. In Panda series, it is a slightly different way of handling these missing values. You will see as we go, right, how what exactly it does. Right. So these are all the operations. I would again encourage you to try these at your when you have time. Please try these operations. Right. These are very similar. Just I'll focus over some of the important ones. Right. So add scalar, compute the natural logarithm, very similar, map a function. So s dot map, what this s dot map does is, if you like want to apply a function over all the values of your series, right? If you want to apply a function over all the values of your series, you use the map, right? One thing you will observe that in every place I have done this dot to list. So what this does is, this will take all the values and convert them into a list and like throw it at you. I mean, not throw it at you, it return to you. So it will take all the values in the series, convert it into a list, right? This, so it will take all these values, convert it into a list, and give it to you. Let's just see it. Yep. So it just takes all the values, converts to a list, returns to you. Right. And rest is yeah, apply some to you can use map as well as you can use apply as well. Both of them do similar stuff only. Right. Then you can use reindex. Reindex is basically, you know, change the index, right? Whatever was the previous index, you just change it. Now let us say you have like the new index has more number of values, like more number of indices you create. So for the missing values, you just fill a value, right? So this fill value equals to 0 means whatever value goes missing, you just fill it with something. Um, there is removing missing entries and there is forward filling missing entries. This we'll shortly see, in the next slides in the session. We'll quickly move into the the main object of pandas, a 2D a data frame object or a data frame data type. Right. So this is a very very I would say elaborate and powerful data type. Right. This can store an entire table with in all the ways you intend to. Right? It can have column names. It can have row indices. Right. So indices are basically here representing rows. So it can have row indices. It can have column names. It can like do every operation which you do with Excel and even beyond. Right? It is right. If you are proficient with pandas, you might not really want to use Excel, given that you know Excel previously. So Excel was the software which is generally used in Excel is generally used in corporate and companies to handle all those tables. If you know pandas, you can like do it in a much better, much simpler way using Python. Right. And the advantage of pandas is like it can handle huge amount of data which Excel cannot handle. Right? It can handle millions of rows, millions of entries, gigabytes, huge gigabytes of data. Like I have the largest data which I have handled with pandas was like some 100 gigabyte of data. 100 gigabyte is a huge data. Pandas can handle such a huge data. Right. So 100 gigabyte is basically a table of size 100 gigabytes. Now, how you actually compute a memory footprint of a table, we'll see in short time. Right. So definition, two-dimensional, size mutable, heterogeneous tabular data structure. So this data type is so complex, we have a new name for it, data structure. Um, we it has something called a axis. So row is labeled by a index, columns are labeled by column names. Rows are called the axis 0, columns are called the axis 1. Right? The key features are the heterogeneous nature, the automatic alignment with NumPy arrays, and corresponding support for vectorized operations, and support for missing data as well. It has like very good support for missing data, which includes you know handling missing data. Like it won't break if your data. I mean, if your table has some missing value, it would break. It would still work. And if your table like you can, it also offers the choice to like drop the missing values in different ways. Right. We will now just quickly move forward to see how we can create data frames, right? How we can create data frames. So this is a short code through which you can like create a data frame. Just write this A. A is the column name. This 1, 2, 3 is the column corresponding column. B is the second column name. This 4, 5, 6 is the column. Okay. So in dictionary we have columns. So the dictionary keys are columns, column names. The lists are basically rows. Um, there are additional ways in which you can like create a view, right? You can like specify, right? Here you, this is basically creating the same data frame, right? So here you have this A column name, and again this A B column names, and you're specifying values, right? So if you enter a dictionary, it is to like specify columns. If you enter a list, it is to like specify rows, right? One by one rows you specify. Inside it you have a dictionary specifying what value is entered in each column. You can also like build it from a NumPy array itself, right? Very simple way. You can also like, if you don't want to do all this, you can just make a table in Excel and save that and import that in Pandas as well. We'll see how we can do that. Reading and writing. So this is where we see. So this is like pd.readcsv. Um, so we can import something called a CSV file. Now CSV is a comma separated file. Comma separated file. You can like see some look in download some CSV file and see how exactly it is being stored, or you can just open Excel and save a table in CSV format. Excel offers that choice. But in case like if you yeah, I mean CSV you can just simply download. If you don't want to do anything, you can just simply go into internet and download a sample CSV data, right? I would be just for showing examples, I would be using a CSV file, and that would be this file. Yeah, yeah, that would be this file, right? So I'll just put the I'll put this um, link. Okay, I will put this link in the here, right? So that you can like access it. Okay. So you just go to this link, and there is this data set. Kaggle is a huge repository of Python codes and data sets, okay, which are very publicly used. This is called a data set, right? This is called a data set. If you want to download, just click this download button, and it should get downloaded in your system, right? So I have already downloaded this, so I won't go there. It downloads as a CSV file, right? So this is nothing but a table, right? This is nothing but a huge table. I have opened it here, so you can see, okay, what exactly is this table, right? So this is basically some information about dogs. This is some information about dogs. We have different dog species, and we have their sizes and different parameters and how they have been rated, right? So what we will do is we will quickly import this data in Collab. So for doing that, what you do is, please also note that Collab also offers some sample data sets, some sample CSV files for you to play around. But then for the time being, we'll just stick to the file we downloaded, and we just drag it and put it here. Like we just come here, we just drag it and we put it, leave it here. We do leave it here, and this basically uploads the file here, and then we can now start to operate. So we write PD. You have to import pandas as PD, right? Beforehand, you have to import it, and then we do read CSV. Read CSV is the method which through which pandas can read a CSV file. Inside, we just import the file name. Please ensure that this. So what we are doing is this file name has to be in the same folder, right? So you have to ensure this that this file name is in the same folder. We just run this, and voila, the dataset has been read by pandas, and it has stored it as a data frame object inside this df variable. So if you want to like access the first five rows, you just do df.head, and you can like print it. Even if you don't print, like if you print, this shows it something like this. If you don't like print it, um, you know, collab shows it in a very interesting format. Let's just run it. Yeah, collab shows it in a very nice user interface. Right. So this shows the first five rows. Right. So these are the columns. Right, and these are the rows. So this 0, 1, 2, 3, 4 are the row indices. This breed, size, energy level, friendliness are the column names. If you want to access the column names, just write df.columns, and this will show you all the columns. If you want to access the row indices, just do df.index, and this will show you the row indices, which here is basically a range starting from 0 going till 20. Right. Now we'll come here. So if you want to like, so after like you made a data frame object, you can do any editing you want inside it. And after you have done that, if you want to like export it into again some CSV file, which you can distribute to your friends, you use this df2 CSV, and this is the file name you want. You can also read Excel files. You can specify the sheet name, and you can also export your pandas data frames into Excel file. Now we'll see what all operations we can do with it. So um, yeah, so these are all the different ways you can import data into Python. Or maybe it might not be all, but majority of the methods. So these are very famous file types. So this is a JSON file type we discussed in the previous session. What's a JSON format? This is the SQL file type. This is a SQL database. HTML read table, basically delimited text file. Right. You can like try all these. Okay. You can try all these. This would be an interesting exercise. But then most important ones are CSV and Excel. Now we'll see what operations we can do over the data frame. Right? We already saw what's ahead. We can, if you put 5, this enters the 5 rows, first 5 rows. If you don't put 5, this still enters the first 5 rows. But then like you can like control it. So if you put 3, it would enter the first 3 rows. This tail is the last 3 rows. This describe. This describe is to summarize statistics. We'll see what exactly it means. Value counts is basically the frequency counts per value. Right? So let me just show all this here. Um, so we'll first see how our table looks. Right. So this is energy level, friendliness, trainability. Right. And this is the breed. This is the size. So first we'll see okay, what are the unique sizes, right? So we'll first access the size column. So how we access the size column? We put a bracket just the way we did all the indexing, and we write size inside. So this will access through this we access the size column. This is nothing but a panda series. Now if I use this method unique df size dot unique, this will give me all the unique values present in that table, right? And if I do something called value counts, This will give me the count for each unique stuff for each unique entry. This will give the numbers, right? How many times large occurs, how many times small occurs, how many times medium occurs, right? Um, Similarly, I can also I'd access more statistics. So yeah, we already saw this df dot columns, df dot index, df dot d types. So if I just do it, yeah. So this gives me the data type. Now this size is basically a string type data, right? So for string type data, both NumPy and Pandas have a common data type called object. So they show it with this O thing. I can see all the D types for the data frame. So for all column, I see the data types, right? So breed is object, size is object, right? So breed is basically, so both these are string, breed and size, both these are strings. So pandas assigned object data type. So you see, pandas, automatically assigns data types. You don't have to specify any data type; it just automatically does it for you, right? So this is very good quality about pandas. If you just do df dot values, this will convert the entire table into a NumPy NDI. Right. This is also very important. Um, you see the object, it assigned the object as well. It assigned a data type as well, which is object. Right. Then we move forward with additional operations. Yeah, the df.info, which shows the number of not null counts. Right. Like here in our table, there are no null values. But then, what stops us from introducing some null values? Let's just open it in this. Double click over this, and you can open it here. Right. I'll introduce some null values. Where will I introduce? Let me Let's see if I can edit it. I don't think I can edit it. Yeah, it doesn't allow to edit. I can only view. So what for editing, what I will do is I'll go to this place and just remove a value. So I just removed a value. I'll save it. And just remember what I valued. Remove so that you know I can replace it later. So I removed the value. I saved it. Now I'll put the updated file. Right. I'll put the updated file inside. So it is now I'll again execute this so that I read it again. df.head I did the changes and the the bottom six. So I'll do the df.tail and I show the last six ones. Yeah, so I removed this trainability thing. So it entered a nan thing. Right. In place of that, it entered a nan thing. So this is how it handles null values. So this is called a null value. Null means no value there. Right. So yeah, df.info would df.info would count all the null value, not null values, and also show the memories. Um, so this we saw how we can access a single column. This is how we can access multiple columns, right? So just remember how we do it. So yeah, this is the IntelliSense of Colab, which shows what all columns are there. So one square bracket, inside it another square bracket, and inside it we write let's access breed, right, and size, right. So this shows both the breed and size, right. So this is accessing two columns. The lock and iLock will so lock is used to access row indices, the row indices which we have. So if we do df.lock, it gives me the first the row in index 1. So this index 1, this entire row is returned to us. It has Chihuahua small 4 3. So Chihuahua small 4 3. Column say 4. Right. Um, there are some additional operations as well, like df.ilock. Now here df.ilock and df.lock would give us the same stuff, since the index is the same as the default index. But I can actually change this a bit. So this was our color table, right? So df.head, this was our table. Now what I'll do is I'll change it slightly. I'll do set index breed, and I'll do in place equals to true. Sorry for the repeated input spellings. Now I do a df.head. Right. So I'll write uh, oops, display here so that both of them get displayed. So if you want to like display this table in this format, you have to put it inside this display function. If you don't, collab by default assumes that the last line of your code is inside a display function. So let's just run it. So initially this is how our table looked, and after set index equals to true, set index equals after the set index operation, this breed column has been set as index. So this breed column has been set as index. So now I can just do this lock operation, and inside I will access the beagle, or I hope I pronounced it correctly with this bagel, whatever it is, df.log bagel, and this shows the entire row corresponding to that entry. So this is how powerful pandas is. Right? You can also do conditional picking up. So I'll again do a df.head so that I have the entire thing in front of me. I can so let me like select all the entries inside the table where the size is large. So for that, what I'll do is df size equal to large. In this manner, I can select all the entries where the size is large. If I want to apply two conditions, I'll do it like this. So df dot I use this this special and, right, and in for this so what my intentions are is I want to select all the entries where size is large and shedding is 4, right? So df shedding is 4. So this selects I have only two entries where size is large and shedding is 4. I can also do uh, you know an OR operation, right? I can do an OR operation as well. For that I use this this thing. This operator is used for OR operation. So this will select me all the entries where size is large. Where either size is large or shedding is 4, right? So here I have size as large. Here I have shedding as 4, right? So this is an OR and an OR. If you like understand, are able to understand it, this is not very like complicated. And is both have to be correct, or is either have to be correct, right? So this is how you can conditionally select parts inside the table. Next we'll see how we can drop a column. For dropping a column, you use df.drop. Inside you just write the column name, right? This access is like optional. You can just write column equal to a, then it will do the same stuff. If you want to drop a row, you just have to write the index corresponding to the row, and you have to mention access equals to 0, right? If you want to add a new column, this is how you can do it. Now I want to add a new column. which is um, which let me see, which is basically an average of energy level and friendliness. So now what that means is energy level and friendliness. So if a dog is friendly but has low energy level, um, you know, the dog would just be lethargic. The dog might be friendly but would be lethargic. But if a dog is, let us say, is not very friendly and has high energy level, that dog is something. I mean, personally, I would be afraid of. Right? It might be something like a Doberman or a Rottweiler. Yeah, exactly. So I want a dog which is a combination of both friendly and energy level, so that it's more amicable. Honestly, I mean, this is more of a personal opinion, but let's say um, we just have a new column, right? Df new is df energy level plus df friendliness, and I take the average of the two, and now I display df new. Sorry, not new. I'll display the entire df. So you see this created a new column here, which is basically an average of energy level and friendliness. So here 4 and 3, it gave me 3.5, right? So this is how you can like add new columns. You can add a new column in this way as well. Key, okay, I add a random column and it should be equal to you know what is this, what is the shape, firstly what is the shape of this data. So this has 20 rows, 10 columns, 20 rows, 10 columns. So I'll make I'll just put a random number, I'll replicate it. So this gives me a list of size 10. Sorry, not 10. I need 20, right? Because there are 20 rows. So now if I do the df dot head, you see I created a new column which has only one. Okay, and it is there till the end. If I don't do this df dot head, it will show me the first 10 rows and the first 10 columns. Sorry, not the first 10. It will show okay, in this case it is showing me the entire column, but for the large but for large data sets, it will show the, as far as my knowledge goes, it will show the first 5 rows and the last 5 rows. Here, since this is a smaller data, since this is for a smaller table, this shows the entire table. Please note this man value which we created, yeah, and this random thing which is there. Right. So this is how you can like create, play around with your table. All the operations you do with Excel are possible here as well. So we saw all these operations which you could do. We'll now move to, yeah, the joins, right? How we can join it. How we can join tables. But before that, let's create a table from scratch, right? Let's create a table from scratch. Um, So I define 4 names. I define a list of names. Okay, and I define a data frame called jobs. Okay, I define a data frame called jobs, which has basically columns are job ID, done by someone, hours taken, how many hours it took for the person to you know do the job, and what was the profit obtained out of that job. Right. So first, what I do is, this might look slightly complicated. I'll break this operation so that you're able to understand what you're doing. Firstly, I'll show you what is this this numpy function do. So let's run this and see what it is giving me. It is giving me an array of size 40. This is giving me an array of size 40, and it is randomly putting values inside it, values within the range 0 and 4. So it is randomly putting values within the range 0 and 4. I can iterate a numpy array. can iterate a NumPy array, and this is how we traverse a NumPy array. So it printed all the values. Now, if you remember, we can manipulate the print function like this. So this prints all the values inside it, right? So every time we call this, this would give us a random array. Now this time it gave us this, right? Now if we again run this, it's a new array, right? So NumPy, what this function does is, this function gives us a random, a array of size 40 with some random, with numbers in range 0 to 4. 4 is not, chosen. 0, 1, 2, 3 randomly picks up a number between, from 0, 1, 2, 3 and just assigns it and creates a size, creates an array of size 40. And for I in this, so what this does is, for I taking the values inside this array, I store names I. Names I is, you know, the, so names I is what? Names I is names ka index I, so index I element. So index I element from names, I just store it here. So if it is 0, it will store Ram. So if I is 0, it will store Ram. If I is 1, if it will store Sham. So basically I'm creating a list. Okay? I'm creating a list where I'm storing, where I'm storing the, okay, I'll describe it in a better way. So what I'm doing here is I'm creating a list. Before creating a list, I created a NumPy array which consists of random numbers in the range 0 to 4 for exclusive of size 40, and then I create a variable which takes numbers from this array, and for that number, it accesses the index corresponding to that number from this names list, right? So this is how it is doing it. Now this is a very interesting way of creating a list, right? So if I just run this, this randomly assigns a, this randomly picks a name from this list and creates, puts it. So it creates a list of size 40, which is, created out of names randomly chosen, right? So this is how you create a, random list. So first I assign, done by, I assign this list. So what I'm basically trying to do here is, um, I have 40 jobs. I have 40 jobs, and I have assigned a job ID to each job. Fine. So this list range 1 to 41. What this does is, this creates a list starting from 1 goes till 41. Goes till 40. 41 is excluded. So I have 40 jobs, and to each job I basically assign a random name chosen from this list. So if I just display the jobs data frame here, you'll see I define jobs with 4 columns, right? Since I have assigned nothing to these, right? These remain nan values. I have assigned stuff only to these 2 columns. So till this time, till this display jobs, I have assigned stuff to only these columns. So I have a job ID, and to each job ID, I randomly assign a employer, right? So I randomly assign a name, and finally, I again randomly assign how many hours it took for that person to do the job, and again I randomly assign how much profit was obtained from that job, right? So if I display the final jobs, so right, first we saw that only 2 columns were assigned, and then we saw the entire table. Let me just do it here. Jobs dot right. So what I'm basically doing is I'm randomly making a table. Now this is called sample data creation. Random data, to be specific, random data creation. Right. So I'm randomly creating a table here. What I'm basically trying to do here is I have some jobs. I'm randomly assigning some fellow to it, and I'm also randomly choosing what how many hours he or she takes, and also again I'm randomly choosing how much profit I gain out of it. Right. So this is my first table, jobs. Okay, which is basically which job was performed by whom, how much time he or she took, and how much profit was obtained from him or her. I mean, from that job. Now I create one more data frame, which is basically the employee details. This empdet means employee details. So this is basically, these names are the names of employees in a company. Let's assume, and yeah, yeah. I created first a table key who did which job, how much profit he or she earned, and then I create another table. Then I create another table which is basically having four columns: name, salary, age, and gender. Right. Name is employee details. Name I assign basically names. I assign one more name. Okay. Now names is the sorry names are is the list I assign. If I do this Aman, this makes a larger list. So I assigned one more name to the list. Their salaries I just randomly put any value here. Their ages again I just randomly put. Their genders as again I randomly put. Now if I display this, what do you see? What do you guys see? Okay, let's just remove this. When I display this, we made a table consisting of employee details. I hope you guys are able to follow this. Now what we do is okay. Now we do some interesting job here. So what I'm trying to do is first let me let's start with some data analysis here. Let's start with some data analysis, and what we are going to do here is first in our jobs table, right? In our jobs table, so this is our jobs table. We want to see how much profit, right? What was the total profit earned by any employee? What was the total profit earned by any employee? So what we do for that, we use a function called group by. Group by done by, and we use the profit obtained, and we write, I would say, sum. So if we do this, pandas gives me what was the total profit earned by individual, you know, employees. Right. So this can also be plotted. If I do plot dot bar, this also gets plotted as well. Right. So this is a very interesting way to analyze data. So this, I mean, we generated a random data, but in companies you have such data sets which you can actually analyze. Right. So let's not plot it now for the time being. Let's leave it at sum only. Right. Now let us say I want I want to see how much in the salary do I give to someone, and how much profit he or she gives me in return. Right. So what I do is I use the function called merge. So in merge, what I do first is jobs emp det. So I merge emp details, employee details, over the jobs table. Let me just show you the jobs table. Right. So I merge the employee details to the jobs table using a left join. Right. And I need a common index. And yeah, let me just run this and show you. So what this is basically doing is this for every name, for every name, I basically took the details out of the employee details and basically merged it here. So for every name and every employee name, I basically took his or her employee details and I merged it besides, right? So this is called a joining. This is called joining. Right? Now I would you know very strongly encourage you guys to play around with this join. There are other joins as well, right, left, right. I am going on a time crunch now, so I cannot explain every thing. But then, yeah. Um, but then you see the power, right? See, I can like extract details from another table and just push it in some other table. Now here, let's. So we after joining it, okay. After joining it, we joined the employee tables. Let's just do a simple operation. I, s- I store this joint data frame into a variable called intel, and then I do a group by over it. So I do a group by over it, and in group by I put a um, I know I'm going running out of time, so this is the last thing which I'll cover in today's session. I'll do a group by on I'll group a group I'll do a group by operation over the done by table, and then I'll just access these two columns and I'll aggregate it. The column, the profit obtained will be aggregated by sum and the salary will be aggregated by me. So if I just do it, okay. So they just did, this both the operations on both the columns. So how we'll exactly do it is um, you do it something like this: salary. Now, these are some advanced data analytics, methods I'm showing. Yeah. So profit obtained has to be summed. So we group by names and we sum the profit obtained by individual. And again, we group by names and we find the mean salary. Now, salary is same for every individual, right? Salary would change. So the mean would be basically the same thing. So what I observe here is what salary I am giving to the person and what is the total profit the person is giving me. Now what I observe here is yeah, Geeta is generating huge amount of profits, but her salary is not very high. While the highest salary is for Sita, and she is not able to generate that many profit. So this is now this is a all randomly generated table. Still, we got some insight over this. As a manager, this you will get these kinds of tables, and when you work in the office, and you actually have to make some decisions based on this. You have actually have to make some decisions based on this. Yeah, Geeta and Ram both are generating very high profits, but their salaries aren't that high. So what should you do? You should you should go for giving them some sort of salary raise or some sort of salary hike, right? So this is what like you should do. I mean this is how you take decisions based on data. Right? So this with this operation, I would like to end this session. Right? Thank you, everyone, to stick to it. We'll continue from tomorrow from where we leave. Your assignment would be to try all these table joins. To try all these table joins over this artificial data set which we created. So create this. I'll give this this entire notebook to you. Your assignment would be to do all the joins mentioned here, all the joins and this concat operation as well. We'll go through it in the next session. Um, so yeah, with this we'll end this session. Thank you for joining. Before leaving, please remember to mark your attendance for this day. You have to mark your attendance for every day. And yeah, if you're interested in the student club, please to reach out to Corso. Uh, Thank you for being there. I hope this was informative. Meet you guys tomorrow. Good night, fellows. Good night, folks. Bye.